Hello friends, continuing with the topic significant figures, today we take up errors. Now, what is an error? Let us try to understand by an example. The least count of meter scale is 1 millimeter, and an observation may be beyond 10.2 and a little less than 10.3 centimeter as shown in diagram. Different students record lengths as 10.27, 10.28 and 10.29 centimeter respectively. Now, made value is equal to exact magnitude plus uncertainty, that is 10 plus 2, which is exact magnitude, plus 0.07 or 0.08 or 0.09, which is uncertain. Fourth digit is uncertain. That is, whenever we state made value of a physical quantity, we include not only exact magnitude of the quantity, but also an estimate of uncertainty in that magnitude. Whenever we state made value of a physical quantity, we include not only exact magnitude of the quantity, but also an estimate of uncertainty in that magnitude. This uncertainty is called as an error. I repeat, this uncertainty is called as an error. Errors are classified into the following two categories. Number 1, least count errors, and number 2, systematic errors. Let us take up one by one. So number 1, least count errors. Least count errors occurs due to resolution of the instrument, which is at the most 0.5 times the least count. I repeat, least count errors occur due to resolution of the instrument and is at the most 0.5 times the least count of the instrument. Now, minimizing least count errors. Least count errors can be minimized, number 1, by using an instrument of high precision, and number 2, by improved experimental techniques. Now we take up second category, the systematic errors. These errors are classified into 5 categories. Number 1, instrumental errors. Number 2, imperfection in experimental technique. Number 3, personal errors. Number 4, random errors. Number 5, gross errors. Now let us take up one by one. First, instrumental errors. How instrumental errors originate, let us see. Now, instrumental error arise due to imperfect design or calibration of the instrument. For example, temperature graduations of a thermometer may be inadequately calibrated. It may read 104 degrees Celsius instead of 100 degrees Celsius, which is the boiling point of water. Example 2, ordinary meter scale may be worn off at 0 end. 0 mark of vernier scale may not coincide with 0 mark of main scale in vernier calipers. So these are some reasons due to which instrumental errors arise. Now number 2, imperfection in experimental techniques. Example 1, to determine temperature of the human body, a thermometer placed in the armpit will always give a temperature lower than the actual value of the body temperature. For example 2, Similarly, other external conditions such as changes in environmental temperature, humidity, and wind velocity during measurements may systematically affect the measurement. Now, number 3, personal errors. How personal errors originate? Let us see. Origin. Personal errors arise due to individual bias, lack of proper setting of apparatus, carelessness in taking observations, without observing precautions, habit formation, eyesight, and effectiveness. I repeat, personal errors are introduced due to individual bias, lack of proper setting of apparatus, carelessness in taking observations, without observing precautions, habit formation of individual, eyesight, and effectiveness. So these are some of the reasons which cause personal errors to introduce into the measurement. Now, number 4, random errors. The errors which occur irregularly and hence are random with respect to sign and size. Such errors are known as random errors. How they originate? Originate due to random, unpredictable fluctuations in experimental conditions. For example, unpredictable fluctuation in environmental temperatures, voltage supply, mechanical vibrations, and personal errors, like the same person, while repeating the same observation, may overestimate or underestimate an observation. Okay. 5. Gross errors. How gross errors originate? Let us see. Gross errors arise due to mistakes by experimenter or by improper setting of apparatus. I repeat, gross errors creep into a measurement due to mistakes by experimenter or improper setting of apparatus. Now, how we can minimize systematic errors? We can minimize systematic errors, number 1, by improving experimental techniques, selecting better instruments, and removing personal biases. We can minimize systematic errors. Random errors can be minimized by statistical methods, in which an observation is repeated several times and the mean value of all the observations is calculated. The mean value will be very close to the true value of a measured quantity. Suppose in an experiment the values obtained during several measurements are A1, A2, A3, so on, An, then A mean will be equal to A1 plus A2 plus A3 plus so on, An divided by n, which is the best possible value of the observation. Okay, this is how we calculate mean value of an observation. Now let us develop the concept of absolute error. The magnitude of difference between the true value of the quantity and its measured value is defined as an absolute error. It is denoted by delta A and mathematically expressed as absolute error. Delta A is equal to true value minus measured value. Now, how to calculate true value? If we know true value, it is well and good. If we don't know, then we consider arithmetic mean of all measurements as true value. For example, the values obtained in several measurements are A1, A2, A3, so on, An. Then true value, say A mean, will be equal to A1 plus A2 plus A3 plus so on, Ai plus so on, An divided by n. Okay, this is how we calculate true value. If it is known, well and good. If it is not known, then we calculate true value by this way. Now mean absolute error. What is mean absolute error? So mean of absolute errors involved in measurements of a physical quantity is known as mean absolute error. It is denoted by delta A mean. I repeat, mean of absolute errors involved in measurements of a physical quantity is known as mean absolute error. And now how to calculate mean absolute error. For example, the values obtained in several measurements are A1, A2, A3, so on, An. Then true values say A mean is equal to A1 plus A2 plus A3 plus so on plus AI plus so on plus An divided by n. Now absolute error in A1 is say delta A1 and it is equal to A mean minus A1. Absolute error in A2 is delta A2 which is equal to A mean minus A2, and in A3 is delta A3 which is equal to A mean minus A3, and so on. In An, absolute error in An say is delta An which is equal to A mean minus An. Now delta A mean is equal to delta A1 plus delta A2 plus delta A3 plus so on plus delta AI plus so on plus delta An divided by n. So this will give us delta A mean. In short form, we can write delta A mean is equal to 1 by n summation delta AI, where I goes from 1 to n. So this way we can calculate, that is delta A mean. Now the absolute error may be positive or negative in some cases, but while computing we have to take numerical values only. And now relative error. Definition: the ratio of mean absolute error to the true value of physical quantity is defined as relative error. Mathematically expressed as relative error is equal to mean absolute error divided by true value equal to delta A mean divided by A mean. Okay. Now percentage error. How we define percentage error? Now percentage error is equal to delta A mean divided by A mean into 100, and whatever comes out to be to write in this bracket, and it will become percentage error. Now percentage error should be less than equal to 5% in an experiment which you do in laboratory. If it is more than 5%, then it means your practical is not successful. You have to do it again. So if you don't get the result, then you have to repeat the experiment time and again till you reach the result. Okay. Now assignment 2.3 continued. Question number 7. The period of oscillations of a simple pendulum in successive measurements are 2.63 seconds, 2.56 seconds, 2.42 seconds, 2.71 seconds and 2.80 seconds respectively. Calculate number 1 mean absolute error, number 2 relative error, and number 3 percentage error involved with the experiment. And your answer would be delta A mean would be 0.11 second and percentage error would be 4%. Okay, so this is for today only. Thank you so much. Tomorrow we'll continue with this topic and we'll take up combination of errors. Thank you so much once again, and God bless you.